हेलो देयर एवरीवन। आज का लीड कोड प्रॉब्लम है 3532 पाथ एक्सिस्टेंस क्वेरीज इन ग्राफ. दिस इज अ graph problem. Here what the question is given, here it is one of the test case. N is equals to 4 nums. There is array of nums 2 5 6 8 is an element. Maximum difference is 2. Queries is this. Let's see the what's the question is really want to say. Okay, so n is equals to 4, so n signify that there are n minus 1 nodes, that is from 0 to n minus 1. Alright, okay, there is a query is given, certain query is given. So let's first make a nodes of all. Okay, so n is equals to 4, so nodes are 0 1 2 and 3. Alright, I have made a nodes. Every graph consists of nodes and its edges, but for connecting edges there may be the condition given. Okay, so here what the condition is given, ki if the difference between let me find out. So there the query 1 is 0 to 1. If 0 to 1 their edge exists, then I have to return true, or if it doesn't exist then I have to return false, and in this way I have to return vector of booleans, right? So let's see, I can make the edge if the difference between this nums of 0th index and nums of 1th index is less than or equals to maximum difference. Hope you get it. Again I will repeat. For the second query 0 comma 2, we have to find whether edge exists or not. The edge only exists if node of I, let's say this is ith node and it is jth node, so nums of I minus nums of j. Okay, the difference between this, let's take an absolute, must be less than or equals to maximum difference. If this criteria qualifies, then we will make an edge, and when queries comes, if the edge possible, if there is an edge, I will return true, else return false. Okay, let's solve out the question. So let's see, let's see 0. Okay, so I will start from 0th. So 0 to 1, will the edge is possible or not? Let's see, 0 to 1, 5 minus 2 3, maximum difference is 2, not possible. Okay, let's say 0 to 2, 0 to 2, 6 minus 2 4, not possible, right? Maximum difference is 2. 2 to 8, 2 and 8 means 0 and 3, not possible. Okay, so 0, leave 0, let's come on 1. Okay, 5. So 5 to 6, possible or not? 5 minus 6 1, yes, maximum difference is 2, possible. So 1 comma 2, there is an edge between 1 and 2. Okay, 5 comma 8, 8 minus 5 3, maximum difference 2, not possible. Let's see, 6 comma 8, 2, so 8 minus 2, 8 minus 6 2, maximum difference 2, possible. So there is an edge between 2 and 3. Alright, now it's query time. 0 to 1, is there any edge? No, return false, so the answer is false. 0 to 2, is there any edge? No, return false. 1 to 3, so 1 comma 3, is there any edge? Let's see, 1 comma 3, there is no edge directly, but if we go through the 2, then there is an edge, right? See, 1 comma 2, 1 and 2, 1 2, the difference is 1 and the maximum difference is 2, yes it is there. And 2 to 3, 8 minus 2, 8 minus 6, 2, maximum difference is 2, and there is this, so there is an edge. So there is no edge directly, but since through 2 there is edge possible, so yes, there will not be false, there will be true. 2 to 3, yes, there is a direct edge, so yes, true. Okay, so as you can see, we can indirectly also take an edge, but there must be an edge, but through 0 there isn't any edge possible because maximum difference becomes less. Okay, so what can be the way to find it out? We can make a graph, right? And in my first opinion, when I was solving, the immediate approach came is that we can make a graph by using hash map, right? Hash list v something, right? But if we see, the whole question is revolving around key whether 0 is part of that connected component or not, right or not. And when there is something, we have to find it out whether the 0 or any element is part of that group or not. The union DSU immediately hit our mind, right? Hope you are aware of the data structure DSU, disjoint set union, because here it will be an efficient approach. If I take graph, then what I can do, there will be the time complexity of O of n square. You can think about it. What I will do, I will just have to go through this. I will first iterate over the queries. I will fetch out the starting and this, right? Then what 0 comma 1, right? So again I will see iterate over this if there is difference possible or not, right? I have to find out for 0 to with each and every element. That means, think about it. If I take the graph approach, what I can do, I will first of all, I will just try to make the connections, right? What I will do, from let's say 0 to 3, and for each element, what I will do, I will just check whether 0 to 1 possible or not. Condition taking 0 to 1, 0 to 2 possible or not, 0 to 3 possible or not, then 1 comes, 1 to 2 possible or not, 1 to 3 possible or not, and in this way it becomes what? O of n square approach, right? So the better approach is DSU. What you can do, hope you already aware about the DSU structure. If not, then please go through DSU and get some information. Okay, so here it's I say good approach in comparison to making the whole graph. There no need to make a graph, in fact, right? When you talk about the DSU, what we have to do, right? We have to just find out whether the 0 is part of that group or not, right? Or 1 is part of that group or not. So let's see. So what I will do, so in this, what we can do, if we think if we sort this out, right? And in this question it is already sorted, so we have to take this whole element as well as index also, and we have to keep in mind that this must comes in sorting manner, right? What I want to say, let's say if I have to come at this way of making groups, right? So what I can do, I will just bind these elements with their indexes, and then I will start taking out these elements one by one, and I will find the what is in ascending fashion, right? And I will find the difference. If it qualifies the criteria, the condition, then what I will do, I will just make both of them in pair, right? Like if I take it out 2 comma 0, let's say, okay, then let's make it as a group. It is itself a group, okay, it is itself a group, okay. Let's then take out another one, 5 comma 1, right? It is itself a group also, it is again itself a group. But if we compare the first element of these each pair, there isn't something, the conditions here fails, right? Here the condition fails. So what I will do, I will then bring another one, 6 comma 2, okay. Now I will not compare it with this 6 because I am moving out the each element in ascending fashion. If this both if the ideal distance, if the difference between these two, if the difference between these two is not less than the maximum difference, then how it can be possible that the number which is greater than this one is less than the maximum difference? It's not possible, right? So why to check? I will not check it now. I will check with fifth one, latest one, right? So here will be 5,61. So condition is okay. So they both form a group. Now I will 8,3. I will take out 8,3. Okay. So if there is a means this both qualifies the criteria or not, they both, okay, this will also get included in this group. Okay, I take out first element, okay, first element, I take out the first element, then okay, the first element is this one. I take out the second element, the second element is anything, but I will try to keep taking out the elements in ascending fashion with only the first element of each pair will be based on that ascending element, right? Based on that ascending fashion. So second element is 5 1, first 2 then 5, okay, they both doesn't fits the criteria, so they will not form a group. Now the first element becomes 5 and the second element becomes 6, right? They both fits the criteria, okay. Now my first element becomes 6, second element becomes 8, they both fits the criteria, okay. Now I get it that 5 6 8 is a what group, is forming a group, but 2 is not forming a group. All right, this is what I want to say. So this is the condition that I will use in DSU to merge the elements to form a group. As you already know that disjoint set union, there we use some type of like a power of each. The whole concept derives on what? There is a group and and in each group there will be a leader, right? So in DSU we form a group, and the node which have the greater influence or greater frequency, we each give the frequency. In generalization, I'm saying there will be a frequency, and on that frequency we used to merge that group, right? Or some power or anything. But here what the condition is that if two elements match the condition, they will form a group. And the second one, another element came, if there is a condition met with any element of that group, then it will form that element also join the group, same group, okay. And the parent of the group can be, you can make it 5 or you can make it 6, anything. Like first here we can make 6 element, right? So by going through this, I came to know that there will be required two variables, the first element and the second element. Each variable contain nodes, and if the condition satisfied, then I will merge them and make a parent either 1 or 2 based on your preferences. I will make here first one. Okay, so if the 5,6 satisfied, which is satisfying, so I will make him parent. Okay, and here parent of this group, whole group. Okay, now 8 will also satisfy, so I will make the parent of 8 is 6, whose parent is 5, so indirectly his parent is also 5. You can make it second parent, second element also, whatever you want, your own preferences. Just I am trying to say that there will be, in this way there will be forming a group. Okay, so let's see the code. You will get a better picture of this whole. And if not, you are not aware of DSU, then you can please prefer or go through the videos on YouTube's, because there are many informative videos. Okay, then come back and try to solve the problem. So here is the code explanation of the question. Okay, to get the question efficiently, I will use the same previous code. As you can see, the query was here only. Okay, so here is the code. Let's see, the main code starts over here. Okay, I am making the priority queue. You remember I told that I will there will be a group. I will take out each group in ascending order, and the target will be the first element of each pair. So here PP defines the pair. So what I'm doing, I make the nums element bind with their indexes. So what PQ is storing? PQ is storing like this: 2, 0, 5, 1, 6, 2, and 8, 3. Okay, storing like this. So here I have made it store. Here I have initialized. Here I have stored binding with their indexes. Here the parent vector I have initialized here, and I am resizing it because it's a global variable, so I am redefining its size. Also the parent one will be here the parent vector will be storing the parents, right? Like there will be the 4 nodes, right? 0, 1, 2, 3. So each node will in starting will be its own parent, okay, of the leader of the group. Okay, right, sorry, 1, 2, 3. Okay, so there will be only each group, and each have one element only, and they were themselves be the leader initially. Okay, so the parent at 0 index is 0, parent at index 1 is 1, parent at index 2 is 2, parent at index 3 is 3, like here. Okay, so priority queue parent. Okay, next. Now I will fetch out the element. So let's see, let's take it. Okay, here is the remember I told that first element, second element, right? So okay, there is something I am forgetting. There will be a temporary PP. Let's write here only. There will be P pair of temporary is equals to PQ dot top most element. Okay, so what was the my priority queues? It was like 2, 0, 5, 1, 6, 2, 8, 3, right? So 2, 0, 5, 1, 6, 2, 8, 3. This was like my priority queues storage, right? It's storing every element. Okay, now priority queue dot top. 2 comma 0. So temporary is equals to what? Let's write here only temporary and current. Okay, so 2 comma 0. Okay, now while PQ is not empty, is PQ empty? No, it is containing 4 sides. Okay, current PQ got top. Okay, PQ got top is 2 comma 0 only. Okay, now let's see. I will pop this element. I pop this element. Now if the difference between this is less than or equals to maximum difference, what was the maximum difference? The maximum difference was 2. Okay, it is 0. The difference is 0. Okay, I will merge them in a group. 2 is already, so okay, there will be a group form only 2. Okay, so group form with 2. Okay, then now I will make temporary is equals to current. The current one becomes my temporary. Okay, let's make it temporary. Now particle is not empty. Particle top is now current. Okay, 5 comma 1 is my current now. 5 comma 1 is my current, because initially you see there will be a leader, right? If there is no any group form, the first element will be leader itself. That's what I am doing with this code. Initially whatever the element will be there initially, that will be the leader. Okay, now here comes the second one, 5 comma 1. So is this valid or not? Not valid. Okay, now I will make this temporary, right? Now I will make this temporary. Okay, now let's see. Now PQ cut top 6 comma 2 I have popped also. Okay, 6 comma 2 is my current one. The condition valid? Yes, it is valid. So now 5 and 6 are in the same group. Okay, 5 and 6 are in the same group. I am merging them. Okay, let's see if the condition satisfied. Yes, it is satisfied. 6 minus 5 is 1. Okay, what is temporary here? Temporary, I think this is my temporary 5. Okay, so temporary ka second is 1 and current ka second is 2. Now I will merge them. How I am merging? Let's see. So initially you remember, right? Each node were parent of themselves. Okay, fine. So what I said, 1 and 2, right? So if I find 1 and 2, here the x is 1 and it is 2. Okay, the parent of 1 and parent 2 are same. Let's see, find parent of 1. What is the parent of 1? Is 1. Parent of 2 is 2. Okay, now I am trying to find out so parent x will denote 1, right? I am finding what is the parent of 1. So it's 1, right? It's 1. How I am finding, I will talk about it, but let's say, so the parent x is equals to 1, parent of y variable is equals to 2. Okay, now what I am doing, parent of 1, index 1, like this, I am making it I'm making it 2. So the parent at index, the whatever element at index 2 is going to be the parent of index x, that is 1. That means now the parent at index 1 is 2, right? Hope you get it. Not 2 is also the parent of element which is at index 1. All right, now how I am trying to find the parent of this, right, element. So it's the recursive solution. I will just find out. Let's say here comes 1, right? So the one parent of 1 is parent of at index 1 and it is 1, is returning 1. When the case will be like this, that the element will be the parent of himself, we will return. Or if that will not be case, then I will find let's say there is a group 1 2 3 and the parent is 1, right? I passed 2 and 2 is 3 is the parent of 2. Okay, 3 is the parent of 2. Okay, 3 is parent of 2. 3 is parent of 2 and 1 is parent of 3. This way, understand in this way. So if I pass 2, is 2 is parent of himself? No. Then return parent of 2, parent of index 2 is equals to find parent of index 2. So here the parent of index 2 is 3. So what I will pass? I will pass 3. So when so here 3 comes. So parent of index 3, which is 1. 1 is equals to the parent. Let's see. Is parent of index of 3, that is 1, it is equals to 3? No, right? So what I will do? So here it will be like parent of index 3 is equals to find parent of parent index 3 is, now I will pass 1. Now here it goes again, parent at index 1, that is 1, it is equals to 1. Yes, it is, it met the condition, right? 1 is equals to 1, parent of 1, that is 1 is parent of himself, so I will return 1. So I am returning 1. So what will be there? Parent of index 3 will be 1. So here it goes again. So parent of index 2 will be 1, right? Hope you understand. This is recursive. If you draw the recursive, if you draw the tree diagram, you will understand. But that's the small piece of code. If you already know the DSU, you must know, right? You have already know about it then. All right. Pardon my writing and my English. Okay. Now I made you understand the merging concept. If the condition valid, then I will then merge them. Okay, here was the group 5, 6, 8, right? The group was formed. Now when I will make this, I will then fetch out the queries. If the parent I have already made, right, is 0, the final parent index will be like this, 0, 1, 2, 3, 0. At index 0 the parent will be 0 only. At index 1 the parent will be 2. At index 2 parent will be 2. At index 3 parent will be 2. So I will fetch out the queries and I will check if the parents are same. Let's say 1, 2. Okay, so both have same parent, so answer will be true. Let's say there was a case, right, 1, 3. So here also see 1, 3, both have same parent, right? That means they belong to the same group, right? So that will return true. So that was all about the code. All right, it's the CBP code. So that was all about. Thank you.